In this episode, we're going to take the vague idea of making the cloud secure and turn it into something you can picture, like walking into a building where the doors, lights, cameras, and fire alarms are already set up in sensible ways before anyone moves in furniture. Security by default means the starting point is safe, and you have to work to make it less safe rather than accidentally ending up exposed. That approach matters a lot in cloud environments because things can be created quickly, copied quickly, and spread across regions and accounts without anyone noticing the risk until it becomes a headline. The other half of the idea is managed services and least management surfaces, which is a fancy way to say you want fewer parts that you personally have to maintain and fewer places where mistakes can sneak in. When you combine those two ideas, you end up with architectures that are calmer, more predictable, and easier to defend, even when you are new and still learning how all the pieces fit together. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. To understand security by default, it helps to first admit how security by accident happens. In cloud systems, you often start with a blank slate, and a blank slate can be dangerous because it is easy to create something that works and only later realize it is too open. A beginner might think the cloud provider is handling security automatically, but providers usually give you tools and options, not a single guaranteed outcome. Many services are secure if you choose secure settings, and risky if you choose convenience settings, and the confusing part is that both options can still function correctly. Security by default is an intentional design mindset where the default settings, templates, and patterns steer you toward safe outcomes. That means you build systems so that creating new resources naturally inherits protections like restricted access, encryption, and logging. When you hear the phrase default deny, it is the same emotional idea. The system should not grant access unless you deliberately allow it. A useful way to think about architecture is to separate what you are building from the platform you are building it on. In the cloud, the platform includes identity, networks, storage, and the control systems that let you create and modify resources. Attackers love the platform layer because it is powerful. If they can change a setting or take over an identity, they can cause damage without ever touching your application. A security by default architecture treats the platform layer like the foundation of a house, not like random plumbing you fix later. You decide what kinds of identities exist, how they authenticate, what the network layout looks like, and how data is stored and protected before you deploy a single business feature. This is not about paranoia. It is about acknowledging that every later decision sits on top of these early choices. When the foundation is consistent and safe, the rest of your security work becomes simpler and less frantic. Now let's connect that to managed services, because managed services are one of the easiest ways to reduce risk when you are new. A managed service is a cloud offering where the provider runs and maintains a big part of the system for you, like patching the underlying software, replacing failed hardware, and handling scaling. The key point is not that managed services are magically secure, but that they reduce the amount of stuff you need to operate correctly. If you run your own servers, you must secure operating systems, apply updates, manage configuration, and watch for drift, and those tasks create opportunities for mistakes. With managed services, many of those responsibilities move to the provider, and your job becomes choosing safe configuration options and controlling who can access the service. This is where security by default shines, because you can standardize those safe options so the managed service is deployed in a protective posture automatically. You are essentially reducing the number of moving parts that can fail. Least management surface is the companion idea, and it focuses on shrinking the areas where humans have to touch things. Every time someone logs into a server, changes a setting manually, or opens an administrative interface, there is a chance of error and a chance of abuse. A least management surface approach aims to remove or reduce direct management paths, especially those that require long-lived credentials or broad privileges. Instead of many servers that each need care and feeding, you prefer services where you manage policies and configuration rather than individual machines. Instead of allowing administrators to make one-off changes, you prefer repeatable patterns that can be reviewed and rolled back. The goal is not to eliminate management, because systems always need care, but to concentrate management into fewer, better guarded places. When you have fewer places to make mistakes, you have fewer mistakes. And when you have fewer administrative doors, attackers have fewer doors to try. A big misconception for beginners is thinking that security by default means locking everything down so tightly that nothing works. In reality, good defaults are not about making the system unusable. They are about making safe behavior the path of least resistance. Think of it like seatbelts in a car. They are not there to stop you from driving. They are there so that the normal act of driving includes protection. In cloud terms, safe defaults might mean resources are private and less intentionally exposed, identities have minimal permissions and less expanded, and logging is enabled without someone needing to remember it. This also means the environment should guide people toward correct choices, like requiring strong authentication for privileged actions or limiting the ability to create internet-facing resources without extra approval. Good defaults reduce the chance that someone accidentally creates a public data store or leaves an administrative interface open. When you get the defaults right, productivity goes up because fewer emergency fixes are needed later. Another important building block is the idea of guardrails, which are controls that prevent dangerous actions or at least make them harder. Guardrails are different from monitoring because monitoring tells you what happened, while guardrails try to prevent certain things from happening in the first place. A security by default architecture uses guardrails to make risky configurations rare, not normal. For example, you might require encryption for certain types of data storage, or you might prevent resources from being created without tags that identify an owner. You might restrict the creation of public network endpoints, or limit who can modify identity permissions. These guardrails help because cloud environments move fast, and speed can outpace careful review. With guardrails in place, people can still build quickly, but the platform nudges them towards safe patterns. The point is to reduce the number of moments where one click can create a lasting exposure. Identity is at the center of this story because in the cloud, identity often becomes the new perimeter. Instead of defending a building with a fence, you defend systems by controlling which identities can do what. That includes humans, applications, and services acting on behalf of tasks. Security by default means you start with identities that are tightly scoped, use strong authentication, and have clear boundaries between routine actions and privileged actions. The principle behind least privilege is simple. Give the minimum access needed to do the job and nothing more. If a beginner hears least privilege and thinks it means inconvenient, it helps to reframe it as damage control. When an identity is compromised, the permissions attached to it become the attacker's tools. So smaller permissions mean smaller blast radius. Building with least privilege from the beginning is easier than trying to remove permissions later when everything depends on them. This is where managed services can quietly improve identity security because many managed services integrate more naturally with centralized identity systems. When you use a service that understands modern identity patterns, you can avoid creating shared accounts, static passwords, or ad hoc access methods. You can separate administrative access from application access, and you can enforce things like short-lived credentials, policy-based authorization, and consistent logging of who did what. The least management surface idea also encourages you to avoid direct access paths like persistent administrator accounts on servers, because those accounts become high-value targets. Instead, you rely on the cloud provider's control mechanisms, where actions are recorded and can be constrained. You are essentially shifting from many small, poorly visible control points to a smaller number of well-instrumented control points. That shift is one of the biggest wins for beginners because it reduces the amount you must remember to secure. Networking choices also affect least management surfaces because network exposure creates management exposure. When services are reachable from the public internet, they become reachable to attackers, and that is true even if the service requires credentials. Security by default architecture prefers private connectivity between services whenever possible and uses public exposure only when there is a clear reason. If something must be public, you put strong controls in front of it, such as strict authentication, limited allowed traffic, and careful monitoring. Beginners sometimes assume that public exposure is the normal way cloud services work, but that is often a habit borrowed from early internet architecture. Modern cloud design often aims to keep internal components private and only expose a controlled entry point. The fewer public doors you have, the fewer things you must constantly worry about. Reducing public exposure is a direct way to reduce the management surface because you are not constantly defending many entry points. Data protection fits naturally into this conversation because the cloud makes it easy to store large amounts of data, and it also makes it easy to share it accidentally. Security by default means data storage should be encrypted, access should be restricted, and sharing should be intentional and visible. Beginners sometimes treat storage like a folder on a local computer, but cloud storage is more like a shared building where access rules matter more than the file itself. A strong default is that data is private by default, and any sharing requires explicit policy and clear ownership. Managed services can help here too, because many managed storage offerings include built-in encryption and access controls that are simpler to apply consistently. The trick is to treat the default configuration as part of your architecture, not an afterthought. When you design the environment so data stores are created with safe access and encryption automatically, you reduce the odds of accidental exposure dramatically. Observability, meaning logging and visibility into actions, is another core element of security by default. You cannot defend what you cannot see, and in the cloud, many of the most important events are not network packets but control actions, like changing permissions or creating new resources. A security by default architecture enables logging in a consistent way from the start and routes logs somewhere central where they can be protected and reviewed. This is not about collecting everything forever. It is about making sure the most meaningful events are captured so you can answer questions during an investigation. If you discover that something was changed, you want to know who changed it, from where, and what exactly changed. If an identity is misused, you want evidence that shows sign-in patterns, privilege changes, and unusual actions. Logging is one of those things people promise to add later, but later is often after the incident. Making logging part of the default state of the environment is like installing smoke detectors before the first fire, not after. A practical way to tie all of this together is to think in terms of repeatable patterns rather than one perfect system. Security by default is less like writing one rule and more like building a set of habits into your environment. You create standard ways to deploy services, standard ways to define identity permissions, standard ways to control network access, and standard ways to collect logs. Managed services and least management surfaces help because they shrink the number of decisions you must make at the lowest levels, where beginners are most likely to slip. The architecture becomes a set of guardrails and defaults that makes safe choices normal, not heroic. When someone needs to do something unusual, the environment can require extra care, review, or explicit approval, which is exactly where you want friction. The end result is not a system that never has problems, but a system where problems are less likely and more recoverable. It is also helpful to recognize the human side of these design choices, because architecture is as much about behavior as it is about technology. If your environment makes it easy to do risky things quickly, people will do them, often without malicious intent. If your environment makes it easy to do safe things quickly, people will do those instead, because humans generally prefer the path that gets them to a working result with fewer obstacles. Security by default is a way to shape that path so convenience and safety are not enemies. Least management surfaces reduce the amount of specialized knowledge required to keep systems healthy, which is especially important for beginners. Managed services reduce the number of chores that can be forgotten during busy periods, like patching or maintenance tasks that get postponed. When the architecture is designed around normal human behavior, it becomes more resilient because it does not rely on everyone being perfect every day. As you build intuition, a final misconception to drop is the idea that security by default means you never have to think about security again. Defaults are a starting point, not the finish line, and attackers change tactics, systems evolve, and requirements shift. What good defaults do is give you a stable baseline so that improvements are incremental rather than frantic. If you start from a safe place, you can measure deviations, notice drift, and make deliberate exceptions without losing control. If you start from an unsafe place, every new service and every new connection increases uncertainty, and it becomes harder to even know what your environment looks like. Managed services do not eliminate responsibility. but they help you focus your responsibility on policy, access, and design, rather than low-level upkeep. Least management surfaces do not remove administration, but they reduce the number of ways administration can go wrong. When you combine these ideas thoughtfully, you get cloud architectures that are easier to understand, easier to monitor, and harder to break by accident. Security by default architecture is ultimately about being kind to your future self and to anyone else who has to operate the system later. It means the environment starts safe, new resources inherit protection, and risky actions require deliberate intent rather than casual clicks. It means choosing managed services when they reduce complexity and reduce the number of things you must personally maintain, while still keeping tight control of identity, access, and data protection. It means treating least management surfaces as a form of risk reduction by shrinking the number of administrative doors and concentrating management into better guarded, better logged pathways. When a beginner learns these ideas early, cloud security stops feeling like an endless checklist and starts feeling like a design discipline with clear goals. You are not trying to build an unbreakable fortress, but you are trying to build a system where safe behavior is normal, mistakes are less likely, and evidence exists when something goes wrong. That is what makes security by default more than a slogan, and that is what makes it a practical foundation for everything that comes next in cloud defense.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.